Hello dear students, this is your Jagan sir. Welcome back to our YouTube channel Physics with Jagan sir. And we were already covered 7 classes in Newton's laws of motion. And each day we are discussing different concept. And today we are going to discuss problems on spring related problems. And see, first point is here. Right, spring force. First of all, let us see what is spring force. See, suppose here a spring is present. This spring is having natural length, natural length, natural length. Now, with the application of certain amount of force, here I am applying certain amount of force. Because of the application of the force, the spring has been elongated a distance x. That means the block has been displaced from initial position to a position like up to here. The displacement is x. This x is called as extension, right? Extension in the spring. Now whenever I am removing that external force, spring will automatically tries to pull the block towards its original position. This original position is known as mean position. The spring will try to pull the block towards its mean position, and because of the presence of inertia, the block will move out of the mean position, and again it will move in the forward direction and it will oscillate. That's a different case. We will see that in the simple harmonic motion chapter. But here spring will try to pull the object towards its mean position with certain amount of force. That force is spring force. And spring force Fs is directly proportional to the amount of elongation, the amount of elongation or extension. That is, Fs is directly proportional to x. Now Fs is equals to kx, where k is the spring constant, and spring constant depends on the material with which it made. If it is iron, it is having some k value. If it is steel, it is having some k value. So depends on the material with which it made, k value varies. And here one most important point is I am representing with the negative sign because spring force try to pull towards mean position. That means whenever a force is trying to pull any object towards their original position, we have to represent them with the negative sign. This is the what is spring force concept. Then next one is, if some set of springs are in parallel combination, how we can use the formulas. What are the formulas we have to use when springs are in parallel combination? Number one is in parallel springs in parallel. Number one is, suppose some set of force F is acting, and because of this force the block will move in the rightward direction. Automatically this spring will pull towards the mean position with the spring force F1, and this with the spring force F2. Now see one most important point here. The extension in the extension or elongation in both the springs remains same. This is one of the most important point. You have to note this because I will let you know why I am saying this is most important. Now, second point, set of the forces acting is equals to F1 plus F2, F1 plus F2, and of course, for sake, you can consider magnitude only, and K equivalent into elongation x value. See here x1, thus extension in the first spring x1, extension in the second spring x2 is equals to the total elongation. So K equivalent, and of course it is having K1 as the spring constant, it is having K2 as the spring constant, right? And K equivalent for the whole system, what is the equivalent K value? That's what we are going to find. And extension in the block remains the same, sorry, springs remains the same. F1 is equals to K1 x, K2 x, right? Now they will get cancelled, and here I am representing x1 is equals to x2 is equals to x only. That's why we are cancelling these two, and K equivalent value becomes K1 plus K2, and if more than 2-3 springs are present, you can add like this, you can add like this. And this is one way of representation of parallel springs. Let us see one more way of representation of parallel springs. Suppose this is the case, it looks like series combination. Originally it looks like series combination, but if you understand very carefully the point which I wrote there, the amount of elongation remains the same, the amount of extension remains the same. That means if it is compressed, the amount of compression in the second spring x1 is should be equals to amount of the extension in the second one. So the amount of compression in the first one is equals to amount of elongation in the second one. Let it be K2, let it be K1, two springs with a different K1 K2 values. Now ultimately the total displacement of the spring remains x, total displacement of the object remains x, which is equals to x1 is equals to x2, and this condition is satisfying for parallel combination only, so immediately what we have to think that here extension is equals to compression, so it comes under parallel combination. Don't consider by looking at the diagram it might be series combination. No, it is not the case. The case has to understand like this. And again, K equivalent value, obviously by substituting and by following the above procedure, you will get it as K1 plus K2. It is one of the most important representation of parallel spring combination. Clear? Then the next point, see here, springs in series. Springs in series. Springs in series means suppose F is the force acting, and remember one case, whenever some set of objects are present in the series, the amount of force acting remains same. That means if it is elongated in the rightward direction somewhat, it is elongated with some rightward direction somewhat, that x value is equals to obviously elongation in the second spring, elongation in the first spring. Then only total elongation will take place. X is equals to x1 plus x2. But for parallel combination, force acting on complete system remains the same. That is, here F is equals to F1 is equals to F2. F1 is equals to F2. That means the amount of force acting in this spring is equals to this spring, and which is equals to total force acting on the spring. And here K1 is the K2. K1 and K2 are the spring constants of the first spring and second spring. Right? Now F is equals to, can I write F by K equivalent, because F is equals to Kx as the formula which we have seen just now. So I can write X as a F by K equivalent. F, and here by using this one, actually I need to write here F1 by X, sorry, F1 by K1, K1, but here F1 is equals to F, that's why I am directly writing. Similarly, F2 means F only K2. So 1 by K equivalent is equals to 1 by K1 plus 1 by K2. This is, and if more than two springs are present, you can add like this. This is the K equivalent when springs are connected in series combination. I hope I am very clear from my side. And next one, let us see some numericals over the concept which we have covered. And remember, physics is such a topic, such a chapter, or such a subject which relates every chapter. And the thing what we are looking here, these problems based on the constraint relations topic which we were covered in our yesterday's class. And today we are going to see constraint relations application in these problems, in solving these spring problems. Let us see the first one. Let us see the first one. On applying a force F, a point P is displaced vertically down by y. See here, a spring is present. A spring is present, and a force is applying here. Because of the application of this force, it is displacing y distance. It is displacing y from the equilibrium position. That means equilibrium means initially it is at rest position, and I am applying certain amount of force and pulling it in the downward direction, and this point is moving downwards by distance y, by a distance y from the equilibrium position. Find force F in terms of the force constant K. That means I need to find this F value in terms of force constant K of the spring, and displacement y. How can I do this type of problems? And before we are going to solve this problem, I would like to tell you here, as I told you in our previous classes, tension force should always represent away from the point of contact. Number one case. So can I write? And second point, Fs is spring force is representing away from the point of contact. Now Fs is equals to 2T. Let it be equation number one. Number two equation is tension is present in the spring and force is the I am applying from the outside. Can I say, as I told you in our previous class again, thread problems, tension in the rope, the problems. There I told you a small, most important information, single thread contains single tension value. So can I say now T is equal to applied force, single thread contains single tension value. That means this tension is equals to F. Let it be equation number two. And third and most important point is if it is displacing y in the downward direction, obviously the spring will extend some displacement by s. Am I right? It will displace some displacement by s. Now, by using our yesterday concept, yesterday I told you some shortcut methods in constraint relation. By using that concept, can I write now? See, this is pulley. So by P, displacement of the pulley in the downward direction is equals to displacement of the spring is equals to, see, it is attached at this point. So 0 plus, it is also moving down, so positive sign only, y by 2. This is a formula I explained you in our last class only. So if you are interested, you can go back to the class again, you can get that knowledge and apply the same thing here. Now ys is equals to y by 2. And what is ys here? Extension in the spring. Ys is the extension in the spring. Now we know that Fs is equals to K by S, spring force. This is what is spring force. Spring force Fs is equals to K by S. That means Ky by 2. And what is Fs value here? 2T. So 2 into T is equals to Ky by 2. And what is T beta? What is T? According to the equation number 2, 2F by Ky by 2. Ultimately, F in terms of K and Y becomes Ky by 4. This is what is F in terms of K and Y. And this is what is first case. Let us go with the second case. I hope Actually, this is one of the most application oriented important critical problems, and this problem actually contains 2 3 different concepts here. Spring concept amalgamating with the constraint relation concept. So you have to be strong in all the concepts thoroughly. You have to practice, then only you will be strong in all the concepts, and which will helps you in solving different types of problems like this, right? Now let us go with the next question, part B question. Here F is applying here, and because of the application of this force, because of the application of this because of the application of this force, this point is displacing by distance, and again they are asking F value in terms of spring constant K and displacement y. They are asking F value in terms of these two terms. Similarly, can I say now it is F means this will be F, and here spring force Fs is acting, Fs is acting, and again single thread contains single force concept. Here it is also equals to Fs. So 2Fs is equals to F applied by the external force, and here when we are applying certain amount of force on this pulley and pulling it in the downward direction by y, obviously it will get a displacement by s. Spring will get a displacement by s. So can I say Fs is equals to k by s, k by s. Now again we need to relate y value and ys value, and again constant relations yesterday concept we can write. See very properly, y pulley is equals to y, this is pulley displacement which is equals to the displacement of the object. So y is equals to 0 0, it is attached at this end, plus extension in the spring ys by 2. So ys value is equals to 2y, ys value is equals to 2y. So Fs is equals to, can I write k into 2y, k into 2y, and again F is equals to 2 Fs means F is equals to 2 into k 2y. So F value is equals to 4ky. This is the force value they are asking in terms of k and y values. I hope I am very clear from my side in understanding these critical problems. And if you are having any doubt, you can comment me in the comment box, right? And next, let us go with the one more problem. And this is one of the logical question, not critical, logical question. Here you need to apply some logic. See, suppose 2m and a spring is present, M is present, right? Two blocks are connected by a spring. The combination is suspended at rest from a string attached to the ceiling as shown in the figure. The spring breaks suddenly. That means it is cutting suddenly with the scissor. Suppose immediately after the string breaks, in your question, whenever you are reading the question, understand these terms which are most important. Immediately means fraction of second. Immediately after the string breaks, what is the initial downward acceleration of the upper block of mass 2m? Now after spring breaks, what would be the acceleration of the 2m mass? What would be the acceleration of the 2m mass? See here, for this type of questions you have to draw free body diagrams. This is one of the most important practice. You have to make it, as a habit of drawing free body diagrams. And first of all, let us draw the free body diagram for 2m. See here, 2m, of course this m will extend in the downward direction, it will move in the downward direction because of the gravity. That means at that time spring will elongate, and whenever the spring is elongating, it tries to pull the object towards its mean position. So can I say that here spring will tries to pull the object towards its mean position with the displacement, suppose it is getting a displacement x, so spring force will act to bring the object towards its mean position, a kx, with the as the spring force. Clear? And second point, mg is acting in the downward direction, that is mass into gravity is acting in the downward direction. And when the thread is cutting, it is attaining the acceleration a. I hope it is very clear. Right? Now I am drawing free body diagram for small mass m, and again spring will try to pull the object towards its mean position. That means spring from like this, it tries to pull these two objects and avoid that x value. That's why spring force is acting in this downward direction, here upward direction. This is fs is equals to kx, and mg is acting automatically in the downward direction always. Clear? Now can I say, for this block, set of all the forces acting in the y direction is equals to actually mass into acceleration. But most important point, whenever we are cutting the string, immediately this will try to move in the downward direction, but spring is still having some extension. Spring is still having some extension, elongation. So this block will remain at rest position only. At that just spark of second, this block still at rest position because it is already elongated. If it is not elongated, obviously this would get the same amount of acceleration, same as this one. Am I right? But extension is present. First point, the extension has to be closed. That extension has to be compressed, and spring has to attain the original position. Then only this will try to move in the downward direction. But the question is immediately. Immediately means this is still at a rest position only. So can I say now? Can I say now? Kx representing in the upward direction, mg representing in the downward direction, mass into 0. So kx value is equals to mg. Let it be equation number 2. So let it be equation number 1. So I hope I am very clear from my side why I am considering acceleration 0 for the mass m, because of the presence of extension of the spring. So immediately means the spring has to attain its original length, then the block m will try to move in the downward direction. But they are asking immediately means it is in extension position, it is at rest position. Clear? Right. Then next point, similarly for 2m mass, see 2m mass is ready to move in the downward direction because the spring is trying to pull towards the downwards. Mg is also trying to pull towards the downwards. So obviously it will try to move in the downward direction because the string has been cutted. Now sigma f is equals to ma. This is the formula about y-axis. So 2mg acting in the downward direction, I am considering for my sake downward direction as the positive direction because resultant acceleration is also in the downward direction. Clear? And plus kx is equals to 2m into a. This is what is the acceleration, and we have seen that kx is equals to mg. So 2mg plus mg is equals to 2ma. This is equals to 3mg is equals to 2ma. Get cancelled. A is equals to 3 by 2g. 3 by 2g. And this is the logical question. It is one of the most important questions actually, these are. And I had explained you critical question, I had explained you logical questions, and I had successfully explained you what is the concept of spring and how can we relate this to the numericals. And I hope you understood the concept, and if you still have any doubts or if you need any extra efforts from my side, let me know through the comment box. Have a great day. And one more important issue, and if you need any material from my side, let me know through comment box. I will definitely post them in our Telegram channel, Physics with Jagan sir. And meanwhile, in a short duration of time, I am about to give some examinations also over the completed topics. So try to follow regularly our Telegram channel, our YouTube channel. Have a great day. Take care. Bye bye.